So first one is that limit x tends to a, f of x is equal to f of a. Then this is one formula, and second formula is limit x tends to a minus f of x, minus means left hand continuity, limit x tends to a plus f of x, so this is equal to f of a. Okay, these two formulas are there. So here, in what cases we can apply the first one, in which case we can apply the second one. So when they given two different functions, then we can use second formula, two different cases. Like see here, for example, question number 5. Second formula, because lesser than condition, greater than condition, both they given. But remaining functions like first one, second one, and even here, third question also, two subdivisions. Okay, like even fourth question. Till fourth question, we can apply the first formula. Okay, so remaining, when they given different conditions like this, we can apply the second formula. Right? So this is continuity. Left hand continuity, this is also can be written as LHC equal to RHC. This is equal to f of a. Or simply we can written as f of a minus, this is equal to f of a plus, this is equal to f of a. So what is the mean by this f of a minus this a minus a plus? A minus means left hand continuity at a. Right hand continuity plus means right hand continuity at a. F of a, the function value at a. So all three values are coincide or equal, then only the graph of the given function is continuous. Otherwise, there is a break. So discontinuity also we discussed. How many discontinuities are there? Here no need to remember. Okay, first kind of discontinuity, again in the two types are there, missing and isolated. A second kind discontinuity is there, in the three types are there, finite discontinuity, infinite discontinuity, oscillator. So no need to remember all these things. Simply remember. So when left, see first formula, the discontinuity which is related to first formula, then this is called first kind, discontinuity of first kind. So what does it mean by that? Limit extends to a f of x not equal to f of a, not equal to f of a, discontinuity, that is called first kind. So left hand continuity not equal to right hand continuity not equal to f of a, this is called second kind. Simply remember that there are only two, like limit extends to a f of x and f of a. Two types, one is missing discontinuity, one is isolated. So what is the mean by missing discontinuity? What is the mean by isolated discontinuity? A simple, for example, in missing discontinuity, right side f of a does not exist. F of a does not exist, then that is called the missing discontinuity. Then what is the mean by isolated discontinuity? F of a is existed, LHS exists, RHS exists. In missing discontinuity, remember that left side is exist, limit value is exist, but f of a does not exist. F of a does not exist, that is missing. Isolated means f of a is exist, but both will be not equal. Limit extends to a, f of x should not equal to f of a. Both will be exist, but both will be not equal. Then isolated. Okay, what are the three types? Because especially NCERT student, so no need to remember that missing, isolated, NEET student I'm saying about. So like they don't ask any question like what is the missing discontinuity, whether the discontinuity belongs to missing or isolated or finite or in, they don't ask like that. Simple, the question is check whether the function is continuous or discontinuous. That's it. Okay, coming to
Sir, I have a doubt, sir.
Yeah.
Sir, if the second condition is fulfilled, sir, LHC equals to RHC equals to f of a, sir, then automatically first condition will be fulfilled, sir.
Here, this one. Yeah, here some cases. What is the mean by here? Here, the meaning of this is, as you said, LHC should equal to RHC. Okay, LHC. For example, see the first question. First question. First question, they did not given any two different functions. Simply they given only one function. So if we draw the graph of this line, this is a line equation. 5x minus 3. Y is equal to mx plus c form. Okay, comparing with y is equal to mx plus c. M value is 5. 5 is greater than 0. Whenever slope is a positive, okay, then it will be increasing. So when substitute x is equal to 0, what is the y value we are going to get here? Take y is equal to 5x minus 3. Substitute x is equal to 0. Y value is minus 3. So, right. This is the, it is passing through 0 comma minus 3. So what they are asking in this question, actually first question, at x is equal to 0. At x is equal to 0, whether it is continuous or not. At x is equal to minus 3, continuity or not. At x is equal to some 5. X is equal to minus 3, x is equal to 5, and x is equal to 0. And these three cases here. See here, it is a line. It is, I said that it is clearly continuous, enter real line, minus infinity to plus infinity. Is there any break? No break. So at minus 3, at 0, at 5, everywhere it is continuous. In the same way, quadratic also, like U shape. Okay, it is x square coefficient is positive, it is open always upwards. It is open upwards. So it is, there is no break for this. But coming to question number 5 onwards, two different functions they given at the same value. Okay. So at
It
this
depends on
condition,
the question, sir.
yeah, it's depending on the question. That only.
Okay.
So limit is exist, but f of a is not exist, missing. Limit and f of a exists, but both will be not equal to isolated. So coming to second one is finite. Finite will be there, infinite will be there. Simple. Finite means both will be left hand continuity, right hand continuity, both will be finite. LHC and RHC both will get a finite value, but both should be not equal. Clearly, I have given a graph example for graph also. For example, this is x-axis, y-axis, this is the graph. Here I am taking x is equal to 1, y value is some 3. And the same x is equal to 1, the curve will be start like this. See here, here I am taking y is equal to 5, but x is equal to 1 only. Y is equal to 5, and y is equal to 3. What do you observe here? It will approach from left side, so the value will tends to x is equal to 1. The value means LHC value is 3, but it will approach to the function till at x is equal to 1. What is the function value? 5. So right hand limit is 5, left hand limit is 3. Is there both will be equal? There is a break if you observe here. This is the example for a finite discontinuity. LHC value is 3, RHC value is 5. 3 not equal to 5, so it is not continuous. It is called discontinuity. It's finite value, both will be finite values. So this is the finite discontinuity. Then second, what I said, infinite discontinuity means either LHC or RHC having any one of the value is having infinity. For example, I define the function here, 1 by x, x greater than or equal to 0. But here's some 2 plus 3x, some x lesser than 0. What do you observe here? At 0, at a particular point 0, there are two values. Substitute 0 here. Greater than means plus. F of 0 plus. What is f of 0 plus? Substitute 0 here. Students, 1 by 0. 1 by 0 means infinite. So what is 0 minus? 0 minus means lesser than condition will give. 0 minus substitute 0 here. 2 plus 3 into 0. 2. See here, one of the limit is infinity. Here RHC, right hand limit. Right hand continuity is infinity, but left hand continuity is finite. Sometimes both will be infinity. For example, I'm going to write one condition, same function I'm taking. Okay, x not equal to 0 given, some 3 x is equal to 0 given. So what is the mean by this? What is the mean by x not equal to 0 means the function they given like x lesser than 0, x greater than, both the cases it will be 1 by x, nothing but what is LHC, that is f of 0 minus, what is f of 0 plus, both will be same or not. Not equal to 0 means both the cases they given same function, greater than, it may be greater than, it may be lesser than, 1 by x only. So in both the cases it will be 1 by 0 infinity. See, so infinite discontinuity means left hand continuity or right hand continuity or both having infinity. The value, limit value should be infinity. At least one value is infinity. We already know that it is discontinuous because limit value is finite, then only it will be continuity. But here we are getting infinity means it is discontinuity. What is the name this? Infinite discontinuity. For example, here both limits are same, but it should not equal to, both limits are same, but it should not equal to f of a. Example, we can give many example ourselves. Can anyone give like that? X not equal to 0. I'm giving simply some 4. I'm giving x is equal to, I'm giving 5. What is the mean by this? Okay, clearly we know that not equal to 0 means x is maybe lesser than 0, x may be greater than 0. Okay, right. If you see here the graph of the function x-axis, y-axis, x greater than 0, the value is, this is 4, this is 5. Not only 0, you can take instead of 0, 1, 2, 3, your wish. Minus 1, minus 2, minus 3 like that. I defined like this. So what is the mean by this? The left hand, the right hand, from right hand it will approach to finally G 4. From left side onwards it will approach to 4 final. So both will be coincide. Left hand continuity, right hand continuity, both will be same at 0, at x is equal to 0. Both will be equal. But what is when x is equal to 0? What about at x is equal to 0? And directly when x is equal to 0 at particular value, the function value is 5. So f of 0 minus clearly equal to f of 0 plus. But it should not equal to f of 0. Okay. So this is oscillation. Oscillation discontinuity. Clearly I have given example because this is twice or thrice I have given example for discontinuity. Do you understand what is the mean by missing? Missing means right side does not exist, left side is existent, isolated discontinuity. Both will be exister, both will be exister, but both will not equal. That is isolated. These are the only discontinuity, 5 types. Next, finite. Finite means clearly I have given here. Left hand continuity value I have given 3, right hand continuity I am giving 5. So both will be finite value, both will be not equal. Left hand continuity not equal to right hand continuity. Finite discontinuity. But any one of the limit is infinite. I give an example here. Plus means right hand continuity is infinity, left hand continuity is 2 to infinity. It is discontinuous. This is called infinite discontinuity. Then oscillation. Oscillation means left hand continuity, right hand continuity is equal, but it should not equal to the function at 0. See example, left hand continuity, right hand continuity is 4 because not equal to 0. means either greater than or lesser than. But equal to 0, it is 5. Both will be again not same. This is 4 is equal to 4, should not equal to 5. This is oscillation. Is it clear to everyone? I hope that very clear. The function which is not continuous, it is discontinuous. Okay. Because remember everyone, this is the basic of fundamental of the entire calculus I told you. So if you're able to understand this, then remaining chapter till 9th chapter, you can easily understand, right? Don't be absent for the classes. Right. What are the problems we completed yesterday? Till question number 13, I think so. 14th and 15th, 16th, I said to do at home. I don't know how many of you completed this. Can anyone complete it? Yes. Students, anyone can complete it. See, you must be practice that continuous. Even you can ask your seniors what is the difficult exercise. Continuity at the same day. At the same day, you have to practice it. This is my sincere advice. I'm saying about only continuity, not saying about differentiability and that. Okay. See, how can you do this 14th question? You can do in this way also. You can draw the real line. It's very easy if you do the same way, minus infinity to plus infinity. Okay, fine. See, here they given different cases actually. 0 lesser than, and I take here 0, here it is 1, then here it is 3, here it is 10. Okay, see 0 to 1. What is the function value? Yes, function of 0 to 1. Function value is 3. Okay, 1 to 3. What is the function value? 4. This is 5. That's it. This is 5. Now, I want to discuss about continuity here. Especially at 1, they given two different cases, that is 3 and 4. At 3, they given two different, 3 is repeated here. Yeah, different cases. But 10 having only one case. At 0 having only one case. The function which is having only one case, and if it is a finite value, then it is continuous. Now, anyone can say 0 to 1, whether the given function continuous or not. Can anyone explain this? Is it continuous from 0 to 1? What about all three functions here? Constant functions. I said very clearly, constant functions are continuous everywhere. Everywhere I said. Am I right? See here, 0 to 1, we're having 3. 3 is a constant function. 3 is a constant function. So clearly it is continuous. So this is continuous. I will write the steps also. Continuous. But at 1 having how many cases? 1 have two different cases. One is what? This is nothing but left hand continuity at 1. This is right hand continuity at 1. Left hand continuity they given 3. Right hand continuity they given 4. Means look at here itself, that 1 At this one, left hand continuity is 3, right hand continuity is 4, 3 not equal to 4. Not continuous at 1. Then 3. Next, see, at particular point 1, then not 1, not 3, between that value, like a 1.1 to 2.999. 1.1 to 2.99, the given function value is for, again, constant function. Constant function always continuous. Okay, between 1 to 3, 4 is a constant, it is continuous. Very carefully you have to understand, and very easy it is. So 0 to 1, between it is 3 continuous. At exactly 1, they given two different cases, left hand continuity, left hand value given, right hand values they given, both will be not same. At exactly 1, it is not continuous. But more than 1, lesser than 3, means 1.1 to 2.99, and the given function value is 4. 4 is a constant, continuous. At exactly 3, because at 3 they given two different cases. So that I am saying about at exactly 3. At exactly 3, two cases, two different values they give. Left hand continuity is 4, right hand continuity is 5. So at exact 3, it is not continuous again. But again, more than greater than or equal to 3, lesser than or equal to 10, 3 to 10, 3 to 10, anyone?
Continuous.
5 alone, again continue, constant, continuous. Okay, so writing that steps and all very easy, but first you should understand where it is continuous and where it is not continuous. So according to the question,
But for 2 ends it is non discontinuous, sir. Like
yes,
1 minus and 1 plus, and 3 minus and 3 plus, it is discontinuous, sir.
exactly.
Okay, sir.
So, okay, we can say that here clearly. What we can conclude clearly, like what are the 5 cases? Here I have written 5 cases. I'm going to write like this. For example, K. In place of X, I'm taking K. K is lies between from 0 to 1. Continuous. Because the function value is 3, continuous. And K value is individually it is continuous. I'm telling you like a shortcut away. And K value is second condition. From where to 1 lesser than K lesser than 3, continuous. Individually it is cut 0 to 1, 3, continuous. 1 to 3, continuous. 3 to 10, continuous. But at exactly 1, not continuous. At exactly 3, alone not continuous. Next I am going to write remaining cases. And here 3 lesser than or equal to X lesser than or equal to 10, it is continuous. But at a particular point 1, not continuous, because left hand continuity is 3, right hand continuity is 4. Now at X is equal to 3, at a particular point X is equal to 3, 3 minus left hand continuity is 4, right hand continuity is 5, not continuous. So how many cases are there? In these 5 cases you need to write. Okay, that I will is it clear? Can you able to write? Can you able to write all these 5 cases? Okay, students. So even if you are confusing at any point, you can ask. You can WhatsApp me. Even this Sunday, I'm planning to take 1 hour. Okay, class. Those are having doubts. If anyone having any concept also, not only problems. If you're having any doubts, concept wise, you can ask. functions, relations, matrices, determinants, inverse. Okay, 1 hour, 1.5 hour, it's depending. Right, you can try this. And question number 15. In every question, first you try to draw the real line, minus infinity to infinity. Right, anyone lesser than 0 is there, 1 is there, only two values. 0, here 0, here 1. Okay, the particular point, see at 0 they given two conditions, at 1 they given two conditions. So that you do one thing, you can draw the circle like open circle like this. Okay, particular point. Now lesser than 0, lesser than 0 here. Lesser than 0 means other than 0, this part. Lesser than 0, what is the function they given anyone? Function lesser than 0, 2x. So 2x is a function from minus infinity to till 0. But now 0 to till 1. 0 to till 1. What is the function they given? 0 to 1. The value, function value is 0. Now more than 1. More than 1. The function value they given 4x. These are the cases they given. Okay, so finally, how many cases they given? Overall, they given 5 cases. That I will write here. Look at once. First one is that k lesser than 0. The function is 2x. Second case, k is equal to 0. Third case, k is like 0 lesser than or equal to k lesser than or equal to r. The third case. Fourth case, k equal to 1. Fifth case, k greater than 1. So all these cases you have to write. Is it difficult to write all these cases? Okay, I will tell you here itself. So please be concentrate here. K lesser than 0. What is the function? 2x. 2x, right? 2x is a polynomial. Is it continuous or not? Minus infinity to till 0. Continuous or not? Polynomial. Continuous. Okay, this is in k lesser than 0, the function is continuous. Next, let us check about k is equal to 0. K is equal to 0, two conditions. This is left side value, this is right side value. Okay, left side value means substitute this 0 here. All of you. Substitute 0. If I substitute 0 here, what is the value? Left side values, left hand continuity at 0. 2 into 0. 0. Right side, right hand continuity already given 0. So at 0, 0 substitute here 0. 0 substitute here 0. So it is continuous. Then between 0 to like from 0 to 1, from 0 to 1. What is the function value? 0. 0 is the some constant, no value. It is always continuous. Okay, fine. It is continuous. It is also continuous. Next, I am going to check at k is equal to 1. So again here we are having two values. Left side is 0, right side is 4x. Substitute 1 here 0. 0 value already 0, no need to substitute. So left hand continuity at 1, 0. What is right hand continuity? 4 into 1, 4. But left hand continuity is 0, right hand continuity at 1 not equal, 0 not equal to 4. So what we can conclude, it is not continuous at 1. But greater than 1, fifth condition. Greater than 1, the function is 4x. 4x is a polynomial. 4x is a polynomial. Is it continuous? Yes, every polynomial is continuous. So at 1 itself, it is not continuous. Other than 1, it is continuous. Okay, one more question. Okay, here I have written 5 cases. In what are the cases we can use first formula? In what are the cases we can use second formula? Can anyone tell that? Anyone? For what case we can use the first formula? What case you can use second formula? Yes. Badma Sharan. Badma Sharan absent. Any? Yes, Badma Sharan. Can you tell me at what cases we can apply first formula? In what cases we can apply the second formula? Second formula is left hand continuity, right hand continuity. Not only Badma Sharan, anyone.
Sir, if k is less than 1.
Less than 1 year. First
Sir,
case.
for k equal to 0 and k equal to 1 alone, second formula, and then for all others, first formula.
Exactly, that is very important. In many times I repeated this. At that particular value alone, you can apply the second formula. Your 1, 0 and 1 are given. So at that particular value 0 and 1, you can apply the second formula. That is second and fourth case you can apply the second. Remaining all case first formula. Okay, function value 2x, like limit extends to a or something. Okay, so k lesser than 0, 0 f of x, that is 2 into 0, that is 0. So next one is f of 0, that is 2 into 0, 0. So the first one, I applied the first formula. But here you should find limit extends to 0 minus f of x at exact 0. That is, you can take 2x, limit extends to 0 minus 2x value is 2x. And f of x value is 2x, 0. And limit extends to 0 plus f of x. Limit extends to 0 plus f of x, 0 plus f of x value directly 0, 0. And one more thing, what is f of 0? Okay, 0 plus 0 minus we found. Then third case is f of 0. F of 0 means we can use like 2x or 0 at equal. Yeah, here it is equal. So we can take f of 0 is equal to 0. All three values are same. So left hand continuity, right hand continuity, function value at 0, all three are same. At 0 it is continuous. But at 1 we'll get the different. I hope that you understood this. Okay, you must be practice.
Sir, but for 2x continuous, we should use the first formula, sir.
Yeah. So in first lesser than
sir,
lesser
in the
than,
same sum we can use different formulas, sir.
yes, yes. See here how to write the first case. You have to write the like this, case 1. Case 1, if k is lesser than 0, k is lesser than 0, function value is 2x. Okay, now first formula you can apply. X tends to 0, f of x. This is LHS, left hand side. Like limit extends to 0, just now I have written 2x into 2 into 0, 0. Then RHS. RHS is f of 0 value is 2 into 0, that is equal. Okay, I used first formula in k lesser than 0. Case 2. Case 2, just now clearly I have written k is equal to 0. Now k is equal to 0 means the functions are approaching from left side to 0 and right side to 0. So that is nothing but at k is equal to 0, two different formulas are there. First, limit extends to 0 minus f of x. So limit extends to 0 minus. 0 minus, what is the function value they given? 0 minus means lesser than 2x. Then limit extends, because 0 is a particular value they given, 0 plus f of x. So 0 plus the function value means 0 they given, 0. Then at x is equal to 0, the function value they given as 0. All three values in. Then like next what you have to write, case 3. Case 3. Yeah, case 3 is 0 lesser than or lesser than or equal to. Yeah, lesser than or equal to x, lesser than or equal to 1. They given a, how many functions they given from 0 to 1? Only one function, that is 0. F of 0 is, f of x is 0. Only one function, that is 0. Now here, same LHS, only one function. But what is the limit you should take here? Simply here, 0 to 1 means you can take like a limit extends to k something. K from 0 to limit extends to k is equal to 0 only, because already 0. And f of k also 0. Both will be same. At any value, whatever you give the value, output 0 only, because constant. K is 4. K is 4 again. K is equal to exactly 1. At 1, because at 1 they given two different functions, so that you can find LHC, that is limit extends to 1 minus f of x value. Then you can find RHC, limit extends to 1 plus f of x, or f of x. 1 minus, what is limit extends to 1 minus f of x value? 0. 0, so that 0. But is what is limit extends to 1 plus more than 1? The function value 4x. That is 4 into 1, 4. And what is f of 1? The function value at exactly equal to 1? 0. Anyhow, your left hand continuity should not equal to right hand continuity at 1. Okay, that case 4 also comes. The case 5. That is k is greater than 1. Greater than 1, only one function is given, 4x. Now same, now LHS, RHS, not LHC, RHC. Left hand side, right hand. First formula. Clear, students? If they understood this concept about regarding to continuity, even OBT questions also becomes easy. OBT questions also becomes easy. Okay, so you try to draw the first real line, and after that you can check that how many cases we are getting. Okay, then you can proceed that. Okay, if you see that, okay, already it's 10:43, 1 minute. I'm writing the different conditions here, minus infinity to plus infinity. What are the particular values? -1, +1. Okay, let's see here. Take the both the values here, -1, here it is +1. Now lesser than or equal to 1. What is the function they given? That is -2. -1 to not include -1 till 1. We can include 1. What is the function they given? 2x. Now greater than 1, we cannot include 1. So 1.12 plus infinity 2. So how many cases are there here? Again, here we are having first k lesser than or equal to -1, and means lesser than you can take k lesser than -1, k equal to -1, and k is lies between -1 lesser than or equal to 1. Okay, k value, three cases. At k is equal to exactly 1. Fourth case, k greater than 1. Fifth case. How many cases? Lesser than -1. First case, use the first formula. At exactly -1, use the second formula. -1 to +1, only one function, first formula. At exactly 1, second formula. Then greater than 1, first formula. 5 cases you have to write when they're given for 5 marks. Like, okay. When they're given for 2 marks or 3 marks, just at exactly -1, at exactly +1 alone you can write. No need to write lesser than condition, greater than condition. Okay. Having any doubts, students?